Hello, my sweet chemists. We are still on the Pre-AP Chemistry Review Acids and Bases on number 23. A zero point 0.2 molar solution of a weak acid is created. The Ka value is 2.3 times 10 to the minus 9. Calculate the concentration of hydrogen and pH of the solution. So the first thing we need to do is remember that our Ka expression is going to be our products minus the concentration of our products divided by the concentration of our reactant. And this is dissociating, so we know that that's what it is. Remember, hydrogen, that's our hydrogen. A can mean any anion. It makes no difference. And then this is just our generic acid. So we have got 2.3 times 10 to the minus 9 is our Ka value, is equal to, now we need to figure that out. So we're going to do our Rice table. So we have our weak acid dissociate into our hydrogen ion and any anion, whatever that is. Our initial concentration is 0.2 molar of our reactant. Our products have not been formed yet, so the product initial concentration is 0. Our change is going to be minus X for our reactant and plus X for each of our products. And then our equilibrium is going to be 0.2 minus X and then X for each of our products. Now once we have this, we can put it into our equilibrium constant. So X and X, that's going to be X squared divided by HA. Now this is a weak acid. Weak acids hardly dissociate. So we're going to say that this X is 0. It dissociates so little that it's close to 0. So this makes it really nice for us because it's going to be a 0.2 and we can disregard that X. All right, so once we have this in our equilibrium, our Ka expression, we can then solve for X. So if I'm solving for X, I'm going to multiply both sides by 0.2. Those cancel. So our X squared is going to equal 2.3 times 10 to the minus 9. Okay, we're not quite there yet. This is X squared, so I need to just solve for X. So I'm going to do the square root of both. That means we're going to have X, gotta do that again. X equals 2.145 yada yada times 10 to the minus 5. If we look at our sig figs, I have 1 and 2, so we can only have 1. So is this 1 going to make that 2 round? It's not. So that will be 2 times 10 to the minus 5. And our concentration is molarity. So this is the concentration of our hydrogen ion. That's our first one. Now we need to figure out what is our pH. So remember that pH equals the negative log of whatever that concentration is. And in this case, it is 2.2 times 10 to the minus 5 molar. Calculate that. Negative log 2 times 10 to the negative 5. And then if we're looking at sig figs, remember when it's in the p log, that means that the significant figure comes after the decimal place. So in this case, we only have one sig fig, so that's going to be 4.7. And that is our pH.